Today we're going to talk about elimination using multiplication. We've already talked about graphing systems equations to solve. We've also talked about substitution, and we've talked about basic elimination with addition and subtraction. Today we're going to talk about using elimination with multiplication. And step number one is the same as others, is to write the system so that like terms with the same or opposite coefficients are aligned. Okay? Step number two. Sometimes we're not going to have the same or opposite, so we've just lined up the like terms. If that's the case, this is when we're going to use multiplication. We're going to multiply one or both equations by a number to create one variable term that has the same or opposite coefficients. From that point, step three is just to follow our elimination rules, which we've already discussed. I'll give you a minute to copy this down, and then we'll move on to the examples for today. Here's our first example. It's already lined up for us with like terms lined up. And if you notice, we do not have any same coefficients or opposite coefficients. But if we multiply this bottom equation by 2, we would have 2x plus 4y is equal to 10. Now we have same coefficients on our variable term with x in it. So let's rewrite both equations. 2x plus 3y is equal to 6. And our equation that we just multiplied by 2, which is now 2x plus 4y is equal to 10. Alright. Since we have the same variable term, we've learned that we're going to have to subtract these equations to eliminate that. So 2x minus 2x is simply 0x, which is 0. A positive 3y minus a positive 4y would be negative y. And 6 minus 10 would be negative 4. So our resulting equation is negative y is equal to negative 4. We don't want negative y, so we can multiply this whole thing by negative 1, which will change this to y is equal to positive 4. So now that we know that our y is equal to 4, we can plug that into either one of these other equations and solve for x. Let's plug it into this bottom equation, original equation. Let's be the easiest one to solve. It would be x plus 2y, which would be 2 times 4, is equal to 5. So we simplify, which would be x plus 8 is equal to 5. Now we're going to subtract 8 from both sides, which leaves us with x is equal to negative 3. So the solution to this system of equation is negative 3, positive 4. We could go ahead and plug this into check as we have in other videos, but for the sake of time, we're going to move on today. Our next system is 2x plus 5y is equal to 3, and negative x plus 3y is equal to negative 7. Again, here if we multiply this bottom equation by 2, I'm going to have opposite terms. So I'm going to multiply this whole thing by a positive 2, which will result in negative 2x plus 6y is equal to negative 14. Let's go ahead and line these up, which would be 2x plus 5y is equal to 3. And the equation that we just multiplied by 2 would be negative 2x plus 6y is equal to negative 14. On this one, now that we have it lined up, we'll take a look at it. Since we have opposite terms here, we know we're going to have to use addition to eliminate that term. 2x plus a negative 2x is 0x, which results in 0. Here we have 5y plus 6y, which is 11y. Here we have 3 plus a negative 14, which would be a negative 11. The resulting equation would be y is equal to negative 11. We'll divide both sides by 11, which gives us y is equal to negative 1. So we know that in our ordered pair, in our solution, y is equal to negative 1. We're going to take that information and we're going to plug it in to one of the other equations to solve for x. Again, I think this bottom would be the easiest. So we would have negative x plus 3 times y. We know that y is negative 1 is equal to negative 7. Let's simplify this. So we have negative x plus 3 times negative 1, which would be plus negative 1, which would be the same as subtracting 3, is equal to negative 7. Our next move would be to add 3 to both sides, which results in negative x is equal to negative 4. We don't want negative x, so we're going to multiply by negative 1. That results in x is equal to positive 4. So the solution to this system of equations is the ordered pair positive 4, negative 1. Our last example shows something just a little different. On this one, if you notice, on the others we had a variable that was had a coefficient of 1. In this one we don't have that situation. We have a 2 and a 5, and we have a 3 and a 2. We could choose to eliminate any of these variables, and to keep our numbers smaller, I think we're going to just choose to eliminate the term y. So I'm going to multiply this top one by negative 2, and when I do that, I'm going to have negative 4x plus 6y is equal to negative 42. Okay, the bottom equation, let's multiply it. We're trying to get this to either the same or opposite. If I multiply this one by 3, that's going to give me 15x minus 6y, and then 3 times 25 is equal to 75. Now that we have it set up, let's go ahead and take a look at this. If you notice in the middle, on our variable term with y in it, we have opposites. We know that when we have opposite coefficients, we need to add to do the elimination. So we're going to add these equations together. Negative 4x plus 15x would result in 11x. Positive 6y plus a negative 6y would be 0y. Negative 42 plus 75 would be 33. So now our resulting equation is y is equal, 11x is equal to 33. We need to divide by 11 to isolate x. In doing so, we end up with x is equal to 3. So a solution to this one, we know that our x term is 3. Now we can take that 3, plug it into either one of our original equations, and we'll just plug it into this bottom equation here. So when I plug 3 in for x, I'm going to have 5 times 3 minus 2y is equal to 25. Well, 5 times 3 is 15, minus 2y is equal to 25. We need to subtract 15 from both sides. So now I have negative 2y is equal to 10. Our next step would be to divide by negative 2, which results in y is equal to negative 5. So our solution on this one would be the ordered pair 3, negative 5. I hope that gives you a little better idea of how elimination works with multiplication. And as you work through your assignment today, be sure to ask any questions.